everyone, welcome back to the channel. Today, we're diving into something super useful for anyone getting started with coding: how to set up a GitHub repository and update your code using the terminal. Don't worry if it sounds a little complicated. We'll keep it simple and easy to follow. First up, we will click the blue New button. This will bring up the Create a New Repository page. Here, the only thing we want to add is a repository name. Don't select a template or a README, no gitignore, none of that. It will put files into the repo that will complicate things right off the bat. Then we get stuck having to fix things. So leave all that alone, just use the default settings. We can always add these later. After we have created it, we have these blocks of code. The first one is the one we want. It has all the commands needed to initialize the repo. Click the copy button to get it on our clipboard. Next, we jump over into our vscode. You then will open a terminal at the root level. The easy way is to right-click a file in the Explorer and select Open in Integrated Terminal. Now, we're ready to paste in the block of code from GitHub. If there are any authentication options that need to be updated, this is typically where they will pop up. The most common issue when getting started is needing to set up your identity. You can read the messages that it prints out in the terminal for more info. Looking through the terminal, you can see where it is listing off what it is doing. You don't have to understand all of it, and you can look over mine here to see what it should look like. When this runs, it will only send up a new README file that it creates. We have to go through and tell it we want it to track all the files, and then it will send them up. A green U means untracked. A yellow M means modified since last commit. To get the rest of our files up, we need to do the commands: git add period, then git commit -m, and our commit message in quotes. For our git add, the period means we want to get everything that has changed and all untracked files. Then in our commit message, we have 50 characters to label our commit in a way that we will understand it later when looking back. Thankfully, when we do a commit, the terminal gives us exact feedback as to what is being added or deleted. Then, when pushing the code up with our git push command, we get more feedback to show what branch the code went to. After executing our git commands, when you refresh the page on GitHub, you should see all of your files, exactly where they were supposed to be. When you use a framework to set up your projects, most of the time you get a gitignore file with all sorts of things automatically added to prevent redundant libraries from making their way onto GitHub. If you don't have one, you will need to add your own gitignore file. You then add each folder name or file name on a new line. This tells Git not to track it, and in turn, it won't go to GitHub. When you delete files in your project, Git will track those deletions and remove them from the repository at that point in the history. I'm going to delete a couple of files here, and then I have this import with a typo in it that we'll fix. After that, we'll push all these changes up as a commit to our GitHub repository. For the purposes of version history, Git is one of the most useful tools to come out for any kind of computer system in a long time. It enables us to see every single character that changes at different points in our project. It also allows us to go back and see our entire project in its current state for each commit. So when you get to a point where you think, hey, this code is actually working right, and I don't know if what I'm about to do will break it, that's a good point to make another commit. That way, you have a safe point to jump back to. I like to go through and let GitHub Copilot or ChatGPT help with documentation to give it a little bit more flair. They can throw in emojis for you at just the right moment to spruce up that README and make it something more attractive for someone to actually read. As you can see here, it does a pretty good job of generating the information that you're going to need. Now, I do recommend going back and proofreading it. I have had it make some pretty big mistakes in the past. You also want to ensure that the emojis it picks really reflect the message you're trying to get across. I'll just make some light touch-ups here, and we should be ready to push the code. Just a few minutes ago, we mentioned that the yellow M shows us that the file has been modified since the last commit. In the source control menu over here, you can also see the files that have been deleted. If you click on a file that has been modified, you will get what is called a working tree version, which shows both the original code and the updates that you have made. The working tree version will show the new code in green, with specific changes in a darker or lighter shade of green. It will display the items that were deleted in red, with a brighter red indicating the specific parts that were removed. You can make changes in this file and save it, and it will also save in the normal version of the file. Now we're ready to go through and do git add period, git commit -m, your commit message, and then git push, so that we can update our GitHub repository with all of these changes that we've made locally. Now, when we jump back over to our repository on GitHub, we can see all of the changes that we made. We can also go through file by file and see all of those changes in a working tree type setup. Additionally, we can take a peek at that README file, which acts as the entryway to our repository for people to understand what we're doing. And that's it. You've covered all the bases here on how to use GitHub for your version control. Now, make sure that when you start a new project, you set up Git right off the bat. That way, you have commits to go back to if you make mistakes.